5 apples in a barrel of 25 apples are known to be rotten. Let's draw a histogram for the number of rotten apples in a sample of 2. So this would be a random experiment. If I reach into a barrel of 25 apples and 5 of them are rotten, how many rotten apples could I potentially pull out? I reach in and pull out 2. How many rotten apples may or may not be in my hand?
2.
2 or
0.
1, right? It's random. Sometimes I might get lucky and have both apples be good. Sometimes I might be unlucky and get both apples rotten, or 1 of each. Okay? So this is a random experiment. Capital X is the number of rotten apples in a sample of 2. That's what's random about this. How many rotten apples did I pull out? And I can pull out either 0 or 1 or 2. So here is our distribution table. I need to figure out what's the probability of each of these specific events happening. Grabbing no rotten apples, 1 rotten apple, or 2 rotten apples, right? So do I pull out 1 at a time, or do I pull out both of them together? Together. Does it matter the order that I grab them? No, as long as they're in my hand, it doesn't matter, right? So this is a combination. We're going to do combinations to figure out these probabilities. I have 0 rotten apples. How many rotten apples are in the barrel? 5, and I need none of them. So the combination would be 5, choose 0. I still need to pull out 2, and I know that both of them are going to be good apples. How many good apples are in the barrel if 5 of the 25 are rotten? 20. So how many ways are there to select from the 20 good apples? I need 2 of them. That's what I want to happen. Out of how many ways in total? How many apples are in the barrel? I need to choose how many? Not 5 of them. 2. I'm pulling out 2 at a time. Okay? So in total, 25 choose 2 with the number of ways to pull out any 2 of the 25 apples in the barrel. Okay, so if I grab my calculator here, NCR 5 choose 0 times NCR 20 choose 2. I get 0.6333. About 63 1/3% chance that I get 2 good apples. Okay, let's move down to the next row in my table. I have 1 rotten apple. So instead of 5 choose 0 for no rotten apples, now it's 5 choose 1. That gets 1 of the 2 apples. What do I know about the other apple in my hand? One of them is rotten, the other is good. So instead of 20 choose 2, now it's 20 choose 1. Aren't I adding a rotten apple and taking away a good apple for every row I move down in the table? Yep. Out of the same combination, 25 choose 2 for in general. So if I type this in, one-third, 0.333. I have a 1 out of 3 chance of getting 1 of the 2 apples that I pull out to be rotten. On the last one, I need both of the apples to be rotten. So adjust this first combinatoric to what? I choose what? 2. I choose 2. Times 20 choose 0. I need no good apples, so none of the 20 good apples. Out of 25 choose 2, or the total number of 2 apple combinations from the barrel.
0.0001.
I'm not sure about that. I think it's 0.333 if I remember this right from last time. 5 choose 2. times 20 choose none, times out of 25 choose 2. 3 1/3%. There is a 3 1/3% chance that we reach in and get 2 unappetizing apples. Now, part A asks us to make a histogram. So we're going to take this table and draw a graph from it. Draw a histogram. I make a graph. The horizontal axis represents X, each of the 3 outcomes, 0, 1, and 2 rotten apples. The vertical axis is the probability of each of these happening. What was the chance I pulled out either 0, 1, or 2 rotten apples? So let's see here. The maximum probability needs to be 63%, so let's just go up to 0.7. Six, 5, 4, 3, 2. I just draw bars to represent the probability of each of these specific outcomes in my experiment. So for no rotten apples, 63.3, so that would be roughly right. In a histogram, the bars are connected. So where this bar ends is where I begin the next bar for my distribution. 1 rotten apple is 1/3 of the time. And then lastly, 2 rotten apples is 3 1/3%. So just a little bit here on the very end. How are you doing so far? Okay, now let's describe this distribution in part B with both its average or expected value as well as the standard deviation. Yep, expected number of rotten apples in a sample of 2. So the expected value of our random variable will be the summation of each outcome times its distribution times its probability. Let's take 0 times 0.6333. 1 times 0.333. 1 times 1/3. And 2 times 0.038. I move down the table, the left column times the right column, all added together. I'm not going to type in the first number because it contributes nothing to the expected value, to the average. I need 1 times 0.333 plus 2 times 0.333. 0.4, 2/5. Every time I reach into the barrel, I should pull out an average or expected number of 0.4 rotten apples. Okay, let's also find the standard deviation in that average. The standard deviation is equal to the square root of the summation of each outcome minus the average squared times the probability. Now, what this means is the average difference from the mean. Standard deviation is the average difference from the mean. Let's first find the difference in each outcome from the average number of rotten apples. What's the total variance or difference from the mean? Since I could be either below average with no rotten apples or above average with either 1 or 2 rotten apples, I need to square it so that it always has the same sign. Then multiply it times the probability, because that is the likelihood that that is the variance for whatever you pulled out of the barrel, the total variability. So let's do this first part. 0 minus 0.4 squared times 0.6333. There's one possible variability. I could have pulled out no rotten apples. That is 0.4 rotten apples less than I would have expected, and that happens 63.3% of the time. I could have also pulled out 1 rotten apple. What's that difference from the mean squared for the variability? And that happens 1/3 of the time. I'm setting each of these possible parts up. The variance times its respective probability. Last one would be 2. 2 apples is 1.6 apples more than I would have thought. And that happens 3.3% of the time. So let's go on to the calculator and add all these up. 0 minus 0.4 squared times 0.6333. I'm going to add that with the next option, 1 minus 0.4 squared. And that happens 1/3 of the time. And finally, the last option, if I got 2 rotten apples, that's 1.6 more rotten apples than I would have thought. The difference in 2 and 0.4. And that happened only 3 1/3% of the time. So that summation works out to be 0.306564. So to put this back in terms of rotten apples, I've squared everything. What's the opposite of squaring something? Square roots. So take square roots of that value. The standard deviation is the square root of the overall variance. Standard deviation is square roots of the variance. Because I squared the differences, to put it back in terms of our situation, I have to take the square root. So square root of that last answer is about 0.5537. So I would expect about 0.4 rotten apples, or differ from that by about 0.55 rotten apples. I have the measure of center and spread from the average for this random variable, rotten apples. Questions here? Okay, tell you what, since you've got your practice pulled up, let's pick one to do here. Could you guys practice number 18? If you just look at the next couple down below. It's very similar, except instead of good and rotten apples in a barrel, now I'm making a city council delegation of different liberals and conservatives. Try number 18. What is the average number of liberals in a given delegation, and what is the average number of conservatives in a particular delegation?